Dear students, today we shall take few more examples for finding out values of integrals based on Cauchy's integral formula. So first example, using Cauchy's integral formula, calculate the following integrals. Integral over c is z upon 9 minus z square into z plus I dz, where c is the circle mod z is equal to 2 described in the positive sense. So first of all we shall find out the points, the poles which lie inside the contour C. So for that, if we put 9 minus z square into z plus I is equal to 0, we get z is equal to plus minus 3 and minus I. Now the circle is mod z is equal to 2, so therefore z is equal to plus minus 3 will lie outside the circle, whereas z is equal to minus I lies within the circle mod z is equal to 2. So therefore we suppose that f of z is equal to z upon 9 minus z square. In fz, leave the term corresponding to z is equal to minus I, that is z plus I. So fz is z upon 9 minus z square. Now we know that f of a is equal to 1 upon 2 pi I integral over c fz dz upon z minus a. That means integral over c fz upon z minus a dz is 2 pi I into f of a, where z is equal to a is a point inside the contour c and fz is analytic within and upon c. So therefore given integral I is equal to integral over c z upon 9 minus z square into z plus I dz can be written as integral over c fz upon z plus I dz, because we have taken fz as z upon 9 minus z square. So therefore this can be written as integral over c f of z upon z minus I. Now use this formula. So therefore this integral is equal to 2 pi I into f at minus I, which is equal to 2 pi I into, put z is equal to minus I here, so we have minus I upon 9 minus I whole square, which is 2 pi upon 10, that is pi upon 5. Let's take next example. Evaluate integral over c dz upon z square plus 2z plus 2, where c is the square having vertices at 0 0, minus 2 0, minus 2 minus 2 and 0 minus 2, oriented in anti-clockwise direction. So let's find out the points which lie inside this contour. This is square. So for that, if we put z square plus 2z plus 2 is equal to 0, we can write it as z square plus 2z plus 1 is equal to 0. That means z plus 1 whole square is equal to minus 1, and minus 1 is I square. So therefore z is equal to minus 1 plus minus I, that is minus 1 plus I minus 1 minus I. Minus 1 plus I in coordinate form, it is the point minus 1 comma 1. So it will lie in the second quadrant, which means it will not lie inside this square. Whereas beta is equal to minus 1 minus I, coordinates of beta are minus 1 comma minus 1, which will lie inside this square. So therefore z is equal to beta lies inside the square. So therefore integral is equal to integral over c dz upon z square plus 2z plus 2. Now because z is equal to alpha and z is equal to beta are roots of this function, this polynomial, so therefore this can be written as integral over c dz upon z minus alpha into z minus beta. Now because z is equal to beta lies inside the square, so we take fz as 1 upon z minus alpha. So therefore integral is integral over c fz upon z minus beta dz, which by Cauchy's integral formula is 2 pi I into f at beta. Now because f of z is 1 upon z minus alpha, so therefore f at beta is 1 upon beta minus alpha. Put the values of alpha and beta here. We have 2 pi I upon minus 2I, which is equal to minus pi. So therefore value of this integral is minus pi. Let's take third example. Evaluate integral over c sin pi z square plus cos pi z square upon z minus 1 into z minus 2 dz, where c is the circle mod z is equal to 3. Now if you put denominator equal to 0, we have z minus 1 into z minus 2 is equal to 0. That means z is equal to 1 or z is equal to 2. Now both these points will lie inside the circle mod z is equal to 3. So we leave the terms corresponding to these two. So we take f of z is equal to sine of pi z square plus cos of pi z square. So therefore I is equal to integral over c fz upon z minus 1 into z minus 2 dz. Now break this 1 upon z minus 1 into z minus 2 into partial fractions. We have this is equal to integral over c 1 upon z minus 2 minus 1 upon z minus 1 fz dz. Because denominator is in the product form, so we break into partial fractions. So this can be written as integral over c fz upon z minus 2 dz minus integral over c fz upon z minus 1 dz. So by Cauchy's integral formula, value of this is 2 pi I into f at 2, and this is 2 pi I into f at 1. Now to find f at 2, we put z is equal to 2 here. So f at 2 is sine pi into 2 square plus cos pi into 2 square, which is sine of 4 pi plus cos of 4 pi. Similarly f at 1, sine pi into 1 square plus cos pi into 1 square, which is sine pi plus cos pi. Now sine 4 pi is 0, cos 4 pi is 1, sine pi is 0, cos pi is minus 1. So calculate this. This comes out to be 4 pi I. So therefore value of this integral over the contour C, where C is the circle mod z is equal to 3, is equal to 4 pi I. Next example. Evaluate integral over c e to the power 3z upon z plus I dz, where c is the contour mod of z plus 1 plus I is equal to 2, which also denotes a circle. Radius is 2 and center is the point minus 1 minus I. Okay. Now if you put denominator is equal to 0, z plus I is equal to 0, that means z is equal to minus I. Now we have to see whether z is equal to minus I lies inside this circle or not. For that we put z is equal to minus I in this on the left hand side. So if z is equal to minus I, then we have mod of z plus 1 plus I is equal to mod of minus I plus 1 plus I. I will get cancelled. So this is equal to 1 and 1 is less than 2, which is the radius of this circle. So that means z is equal to minus I lies inside C. So therefore leave the term corresponding to z is equal to minus I, that is z plus I. So take f of z is equal to e to the power 3z. So therefore by Cauchy's integral formula, integral over c e to the power 3z upon z plus I, which can be written as z minus minus I dz, is equal to 2 pi I into f at minus I. F at minus I is e to the power 3 times minus I, that is e to the power minus 3i. So therefore this integral is 2 pi I into e raised to the power minus 3i. Next example. Evaluate integral over c z square minus 4 upon z into z square plus 9 dz, where c is mod z is equal to 1. So if you put denominator is equal to 0, we have z is equal to 0 or z is equal to plus minus 3i. Now you can see that z is equal to 0 will lie inside the circle, and these 2 points plus minus 3i will lie outside the circle C. You can verify also. Suppose z is 0, then what is mod of z? Mod of z is 0, which is less than 1. That means z is equal to 0 lies inside C. and if we take z is equal to plus minus 3i, then mod of z is mod of plus minus 3i, which is equal to 3, which is greater than 1, means radius of the, which is greater than radius of the circle. So that means these 2 points will lie outside the circle C. So therefore we leave the point, we leave the term corresponding to z is equal to 0, which lies inside the circle C, and therefore our fz is z square minus 4 upon z square plus 9. So therefore I is equal to integral over C fz upon z dz, which can be written fz upon z minus 0 dz. By Cauchy's integral formula, this is 2 pi I into f at 0, which is equal to 2 pi I into, now f at 0, put 0 here, we have minus 4 upon 9. So this is equal to minus 8 pi upon 9. Next example. Evaluate integral over C. C is missing, please take care. This is integral over C. E to the power 3iz upon z plus pi whole cube dz, where C is mod of z minus pi is equal to 3.2. So if you put denominator is equal to 0, we have z plus pi is 0, that means z is equal to minus pi. Now for z is equal to minus pi, what is mod of z minus pi? Mod of z minus pi is mod of minus pi, which is equal to 2 pi, which is 2 multiplied by 3.14, that is 6.28, and 6.28 is greater than 3.2, which is radius of this circle. So therefore z is equal to minus pi lies outside the contour C. So therefore, because this point lies outside the C, therefore this function e to the power 3iz upon z plus I whole cube will be analytic within this contour C. There is no singularity of this function and it is analytic within C. Therefore by Cauchy's theorem, fz is analytic. Because fz is analytic inside and on contour C, therefore integral over C fz dz is 0. That is integral over C e to the power 3iz upon z plus pi whole cube dz is equal to 0. Evaluate integral over C dz upon z square minus 1, where C is x square plus y square is equal to 4. This is a circle having center at 0, 0 and radius 2, means mod z is equal to 2. Suppose that I is equal to integral over C dz upon z minus 1 into z plus 1. So if you put denominator is equal to 0, we have z is equal to plus minus 1, and both of them will lie inside C. So therefore I is equal to integral over C dz upon z square minus 1, break into partial fraction, this is equal to 1 by 2 integral over C dz upon z minus 1 minus 1 upon 2 integral over C dz upon z plus 1. So therefore by Cauchy's integral formula, this is 2 pi I into f at 1 and this is 2 pi I into f at minus 1. Take 1 by 2 outside the square bracket. So which is equal to 1 by 2, 2 pi I into, now what is f at 1? F at 1 is 1. Minus 2 pi I into f at minus 1, f at minus 1 is also 1. So therefore these two will get cancelled and this is equal to 0. Let's take last example. Evaluate integral over C 4 minus 3z upon z into z minus 1 z minus 2 dz, where C is mod z is equal to 3 by 2. So if you put denominator is equal to 0, we have z is equal to 0, z is equal to 1, z is equal to 2. Z is equal to 0 and z is equal to 1 will lie inside C, whereas z is equal to 2 will lie outside the contour C. So therefore leaving the terms z and z minus 1, we take f of z is equal to 4 minus 3z upon z minus 2. Therefore I is equal to integral over C f of z upon z into z minus 1 2z, sorry dz. Now break it into partial fractions. We have this is equal to integral over C fz into 1 upon z minus 1 minus 1 upon z dz, by Cauchy's integral formula, this is 2 pi I into f at 1 and this is minus 2 pi I into f at 0. Now f at 1 can be obtained from here. Put z is equal to 1, so 4 minus 3 upon 1 minus 2, which is minus 1, and similarly f at 0 is 4 minus 0 upon 0 minus 2, that is minus 2. So we have 2 pi I into minus 1 minus 2 pi I into minus 2, which is minus 2 pi I plus 4 pi I, which is equal to 2 pi I. So the value of this integral is 2 pi into I. Thank you so much.